Hello students, now I will tell you the thermodynamic changes or thermodynamic processes. Changes. Number one, isothermal change. Number two, adiabatic change. Number three, isobaric change. Number four, isochoric change. These are the four. Basically, we have only the two, the isothermal and the adiabatic. Remaining isobaric and isochoric are the changes which are not to be here that we will take. So most we will take the two processes, isothermal and adiabatic. So first I am taking the isothermal change. The change in which the temperature of system remains constant throughout the process. Throughout the process. It means that if suppose system is allowed to expand, then the internal energy of the system will decrease. So at the same time, the same amount of heat must come inside the system so that the temperature remain constant. If suppose system is allowed to contract, then the temperature of the system will increase. It means that the internal energy will increase. So to keep the temperature constant, whatever heat is produced in the additional amount, this must go out of the system. So there must be a good communication of the heat between the system and the surroundings. This change takes place very slowly so that the heat could be exchanged between the system and surroundings. It means that the heat must get the sufficient time to go out of the system and to come inside the system. So to keep the temperature constant, this process takes place very slowly. But if the system is made of very perfectly conducting material, then this process can be done rapidly also. If the system is made of perfectly conducting material, the change can be the isothermal change can be done fast. So since perfectly conducting is not possible, so normally this is done at a very slow rate. Since perfectly conducting material is not possible, so it is carried out very slowly. So this change is taken to be very slow. And now you can see that if we apply the first law of thermodynamics, in isothermal change, du is equal to 0, means no change in internal energy of the system. No change in internal energy of the system. Then first law of thermodynamics, by first law of thermodynamics, delta Q is equal to du plus delta W. So what we say that in isothermal change, du equal to 0, therefore delta Q is equal to delta W. It means that whatever heat is given to the system, that will be used to in the work done. So in isothermal change, the heat given to system will be used to work done. And such systems we can say that in this case the temperature remains constant. So the equation of state PV equal to constant. This is the Wiles law. Wiles law. And if we draw the PV diagram of this, then this is now your pressure on this side, this is now volume, so this will be like this. This is P proportional to 1 upon V. So, and if you draw the curve like this is now pressure, this is 1 upon V, then you will get a straight line P proportional to 1 upon V. And you say that this is the isothermal curve. Say this is for the temperature 1, then you can see that if we draw different isothermal curves, then they will not intersect with each other. The isothermal curves never intersect each other. It means that if we draw the curve like this is suppose your pressure, this is now your volume, then we draw the curve like this. There may be many curves. This is suppose for temperature T1, this is for temperature T2, then this is temperature T3. So for different temperatures there will be the same curve, will be the different curves, but they will not intersect each other. So they are parallel to each other. So this gives you the idea that during the isothermal change, whatever we draw the variation of pressure with the volume, that will give you the curves which are parallel to each other and with the different temperatures. Now we'll take the work done in isothermal change. So you like, share and subscribe this video. Thank you.